Hello, my course project is a ride-hailing app recommends that users combine route planning with public transportation during rush hours. I'm in Beijing, China. The problem is Beijing is a city with a large population and heavy traffic congestion during rush hours. So when people want to take a cab during rush hours, they will often difficulty getting a taxi in time, and there is a traffic jam nearby, and the cars taking orders are stuck on the way. But on the other hand, some non-congested areas are easier to get a taxi quickly, and on some roads, taking public transportation may be less time consuming than taking a taxi during rush hours. So I think why not combine public transport and taxi hailing to make up for each other's weaknesses? So I think there is a problem that in large cities with large populations, the taxi difficulties during the rush hours, and the people who take taxis want to get to their destination in the least amount of time. And the users of ride-hailing apps during the rush hours will carry it, and the taxi operator and the government transportation department will carry it. Can ML help solve it? I think yes, although it's a bit difficult and computationally expensive, but I think it is worth trying. So let's define the problem. The target user is that users who use taxi hailing apps during the city's rush hours. And the problem statement is that when the user takes a taxi during the rush hours, the software plans the trip route according to the depth and the destinations set by the users, and the apps will guiding the user to quickly arrive at the place where it is easier to get a taxi by taking nearby public transportation, or the apps will guiding the user to get off at the designated place and take public transportation to the final destination. This will take less time than a full taxi ride. Why it matters? I think it can help users save time and reduce costs caused by traffic jams, and it can help taxi operators increase their operating income, and it can help governments reduce the traffic congestion and increase low carbon travel and environmental friendliness. The problem has not been well solved, uh, and the operating companies only adjust the taxi price by time segment and region to affect people's taxi decision making now. Let's define success. The expected impact is that it can shorten the user's hold time and shorten the traffic jam time of empty taxis. And it also can increase the operating income of the taxi operating companies. The outcome I stated is that the reduced commute time for taxi users and the daily revenue growth of taxi operators. The output is that the MSE of model predicted route time versus actual time, and the constraints is that it must be combined with accurate real-time forecast data for the operation of public transportation, such as bus or subways. And there is some another potentially factors such as weather, season, the working days or the holidays. Is there a major event and the traffic manager policy changes can also affect that. So the solution is when users use the ride-hailing apps, the apps will locate the user's current position, and the users will set the final destination. The model will use the big data and the user's information to predict the route plan. And the route plan will combine public transportation and the taxi information. So user can uh, go to the designated pickup point by public transportation. It is faster, and then take the taxi to the destination. It compare traditional ride-hailing app. It can reduce time that user waiting the taxi, and it can shorten the traffic jams times. I will validation my plan use 3 steps. The project is mainly aimed at users who take taxis in rush hours, so the potential users need to be filtered. So in the first step, I will collect the potential users' taxi habits and opinions on solutions through questionnaire survey to verify whether potential users are willing to sacrifice some convenience in order to reach the destination as soon as possible. The second step, I will use a simple page prototype to simulate the interactive process of the project in actual use. And the third step, I will find some representative routes at different times and in different regions. And I will use the A/B test to compare which can reach the destination faster. So my ML system design, I will use the cloud because the amount of data is huge and requires high computing power. Users take a taxi using a mobile app, and the computing power and memory of mobile phones are currently not fit for big data. And then I will use online learning because during the rush hours, the location of taxis on the road changes dynamically in real time. The model must respond quickly to the changing traffic and then maintain the predictive performance of new data. So it needs to learn at a high frequency. And I also use the online prediction because the time of users to take a taxi is not fixed, and the road traffic and the taxi operation conditions are also in dynamic changes when taking a taxi. So real-time predictions needs to be made according to the data at that time. The latency and the data drift will be the potential risks. The network signal, network speed, calculation speed, and other factors may cause the latency. That will affect the accuracy and the timeliness of the model prediction. To reduce the latency, increase cloud computing power as much as possible, such as add local computing centers, carry out in-depth feature engineering to simplify features, and use offline learning for some features. In terms of software design, user can be encouraged to reserve taxi in advance so that the models can make prediction as early as possible. Changing traffic conditions, weather, and special dates can affect the performance of model prediction. So it is important to ensure that the model is up to date with the data in real time. Okay, that's my course project report. Thank you very much.